Okay, we're on problem number 7 here, and we're told that this exercise is about the equation y minus 4x is equal to 9. Okay, so this is an equation y minus 4x is equal to 9. So this is not an expression, it's an equation, and we're also told to do several things. To copy and complete the following table of some of the solutions of this equation. So we're given an x value, and we're simply going to plug in and find the y value. We've done this before. Now, the question, it says in letter B, what happens to y if x is decreased by 1? Okay, so the observation you need to know is what's going on. You're looking now at the relationship of one variable to the next variable, and then the next thing you're going to do is plot these points as their in this table as their coordinates in the graph. And again, this is something you've already done. All you do is take the x value and you look for the x value, and then you find the y value and you plot your point. And then the next thing you'll have to do is observe the graph and determine what you may notice about these points. Okay, so these are similar to prior lessons that you've learned. We're now moving forward in terms of our math and the complexities of the things that you've learned. You've learned these on simple levels. Now we're going to start developing these in greater levels. And in number 8, we're told, if possible, find every pair of positive integers that can replace x and y in each of the following equations to make it true. If you think that an equation has an unlimited number of such solutions, or that it has no solution, then you say so. So how would you do this? Well, we're told first that we're only supposed to use positive integers. Okay, so if we take the first one and we say x plus y is equal to 6, then we know we can only, if we're only using positive integers, that means, well, what's the first one? Well, it's 1. Okay, so why don't you make a chart here, and you could do something like this. All right, and you could just say, well, how about 1 and 2 and 3? And if I start plotting this in here, well, if x is equal to 1, y is going to be equal to 5. If x is equal to 2, y is going to be equal to 4. If x is equal to 3, y is going to be equal to 3. What happens if I have 4? Well, if x is equal to 4, y is equal to 2. If x is equal to 5, y is equal to 1. And if x is equal to 6, y is equal to 0, well, I have a problem here now. Because 0 is really not positive, it's neutral. So I would not be allowed to use this. In fact, we didn't start with 0 because 0 is not a positive integer. In fact, then we cannot continue, because if we were to go to 7, then the only way this is possible is that y is equal to -1. And again, this does not fit. So we do have a finite group of answers here. 1, 2, 3, 4, 5. These are the x values. So the answers would be 1, 5, right? 2, 4, 3, 3, 4, 2, 5, 1. So those are the answers. And you know, you're going to get challenged in this, but always remember, you're only dealing with positive integers, so you always start with 1. You're dealing with integers, you're not dealing with fractions or decimals, so you do have a certain limitation, and you may be able to find all the answers in some of these, but in some cases it may be true that there are an infinite number, because as long as you're plugging in values and you're meeting the requirement of positive integers as both x and y, then you may come to the conclusion that, wow, there's an infinite, because I can keep putting these in and I'm noticing that the numbers are moving in the right direction, and there's no limitation. So that's how you work problem number 8.